Now we are moving on to kinematics, as you can see written on the display, and the first question has been selected under this topic kinematics is 9709/41 for the session May June 25, and as you can see it is question number 7, which is a particle x moves along a straight track starting from a point O at time t equal to 0. The displacement of x from O at time t second is s meter, where s equal to 3t raised to 3 over 2 minus 60. Find the time at which x is instantaneously raised and hence find the total distance traveled by x between t equal to 0 and t equal to 16. Let's start our solution, and before solution I am going to erase these writings. There are two parts of this question. Number one is the particle was at rest. At rest means when a particle is at rest, then velocity is zero. So one of the time should be obtained when the velocity was at rest, I mean velocity was zero, and the second one is total distance. So first part of the question, s is given, displacement expression for displacement is given, which is s is equal to 3t raised to 3t raised to 3 over 2 minus 60. And for velocity, if we integrate, sorry, if we differentiate the displacement expression, then we will get our velocity. So let us find the derivative of this ds over dt in terms of time. If we differentiate displacement, it is going to be 3 over 2 into 3, and the power of t is getting decreased by 1, it is going to be half, minus it is going to be only 6. Well, then we can write v is equal to, hence our expression for v is, it is 9 over 2 means 4.5. We can write 4.5 square root over t minus 6. Then they have told that the particle was at rest, so we can write at rest. At rest our velocity is 0. That means 4.5 square root over t square root over t minus 6 equal to 0. Then directly we can find the value of t. What is it going to be? T is going to be t equal to 6 over 4.5, and for square root we will multiply both sides by 2 power 2s power. Hence our time is going to be 16 over 9. 16 over 9 is the time when the velocity of the particle was 0. This is one of the answers. Okay, we can write here answer notation, because they have told us to find the time when the particle was at rest. Then the second part, we'll have to find the distance. Then we are going to find the distance traveled by the particle between the time equal to t equal to 0 and 16. And for that, it will be better for us to understand the nature of the curve. Let us draw the curve of this. It is, so t second, and initially look at this. Initially, for velocity time graph, let me write here v meter per second, v meter per second. Initially look at this, the velocity expression is this. So this is our velocity expression. Okay, and for velocity expression here it is 0. And initially we can see that when the particle started its journey, the velocity was -6. -6 when t is equal to 0. Look at this. If you substitute t equal to 0, then velocity will be -6. So initially velocity was -6. Then at 16 over 9 points, it was at 0. Suppose here there is 16 over 9. The time is 16 over 9, and we are going to find when the time was 16 seconds. So what was the nature of the curve? The curve was somewhat like this. Okay, it is a negative curve. Sorry, it's not a negative curve, it's a positive curve. It will look like this. Well, now according to this graph, if we look at this first phase of the particle is lying below the x-axis. From 0 until 16 over 9, the particle is moving below the x-axis. That means surely these velocity, I mean this displacement, this distance is surely negative, because it is lying below the x-axis. And the second part is over here. Second part is this part is lying above. Let me change the ink. For the second part, it is lying above x-axis, so it must produce the positive value of area or displacement or distance, whatever you tell. Okay, so for the first phase, it must be negative. That's why we will write already we do have the values, I mean displacement expression. So there is no necessity of integrating this. Just we will write for just below this, we are going to write for the first phase. For 0 until when it was at rest, 16 over 9. 16 over 9, our displacement or distance expression is S1. You can write S1 as this is the first phase. S1 is equal to 3 into T. T raised to what? 3 until 2, and our time limit is from when to when? 0 until 16 over 9. Okay, 16 over 9 minus 60. So 60, and our time limit is 0 until 16 over 9. 16 over 9. Now if we simplify, it is going to be 3 into, let us write 16 over 9. 16 over 9, and our exponent is 3 over 2. 3 over 2 minus 6, and that is also 16 over 9. Okay, 16 over 9, but here we will have to write this minus 6 into 16 over 9, because look at this, as our lower limit is 0, so multiplying something by 0, it will also be 0. And finally our S1 is going to be, using our calculator we will find that. And remember, already we have come to know that as this portion, the black portion, the first part is lying below x-axis, it will produce a negative value. So we will have to write a negative value or modular symbol. Whatever you do, you can do anything, but it must be negative. So this is negative value, hence it is also negative value. Okay, so finally, if we use our negative symbol, it is going to be positive. This 96 over 9, then minus, it is going to be 3, then 27. So 9, it will be 64 over 9. 64, because 4 cube means 64, so 64 over 9. Then finally our first part of this displacement is 32 over 9. It is 32 over 9. So 32 over 9 meter is the displacement travel in the first phase when the particle was at rest, instantaneous rest. Then for the second phase, let me change the ink. Okay, we will write for for the second phase our time is what, from 16 over 9, 16 over 9 until 16 second, until 16 second. Well, let it be termed as S2, second phase or second part of the displacement, S2. And our expression is 3t raised to 3. So we will just substitute the values. 3 and t is going to be t raised to 3 over 2, and our limit is from 16 over 9 until 16, minus 6 into, then t, our limit is what, from 16 and 16 over 9 until 16. Okay, now if we substitute our values, we will get S2 is equal to, so 16 raised to, remember we don't need to put negative symbol at the beginning because it is already lying on the above x-axis. So it is 16 square root over 3 over 2 minus 16 over 9, and the power is 3 over 2, minus, outside that there will be 3, here there will be 3, then minus 6 into 16 minus 16 over 9. Finally, we are going to get S2 is equal to 3 into, it is going to be 16 raised to 3, means it is going to be, so 4 cube, 64. 64 minus, this is going to be 64 over 27. 64 over 27 minus 6 into, it is 9 over 9 16, 144. 144 minus 16, that is 128. We can easily write it 128. Well, after that, if we simplify more, it is going to be, after simplification using our calculator, we will get, it is going to be 896. 896 over 9. This is the second phase of the displacement. Now we will find the total distance. So the first distance was this, 32 over 9, means this portion was the first distance, and second distance was this. So we can write total distance, distance equal to, we are just going to do addition. 8, this 2 should be added. So second phase is 896 over 9 plus 32 over 9. 32 over 9, and using our calculator we will find that our displacement is, if we round it up to three significant figures, it is going to be 103.1. So 103 meter is the total displacement. That is what the that is what everything about the answer to the first question. It may look very clumsy because I don't have space to write either sidewise or downward. So that is the solution to part A. Let's see what B says. Question number B says, It says a second particle y moves along another straight track starting from a point P at time t equal to 0. The acceleration of y at time t second is a meter per second square, where a is equal to zero point 0.8 minus zero point 0.6 t. The velocity of y when it leaves P is 7.5 meter per second. When the velocity of y is negative 9.6 meter per second, show that the displacement of y from O is equal to the displacement of y from P. So for the particle B, particle y, the velocity is given but time has not been given. We should find the time, and at that same moment how much was the distance of particle x also. So first of all we'll have to find time, and before finding time we'll have to move back to velocity. They have given the expression for acceleration, so we can write ay, acceleration of particle y is equal to zero point 0.8 minus 0.60, and if we integrate we will get velocity, or we are integrating in terms of time, equal to, if we integrate 0.60 it is going to be zero point 0.3, 0.3, because if we divide zero point 0.6 by 2 it is going to be 0.3 t square, and it must be negative, plus zero point 0.8 t, zero point 0.8 t. So our velocity is negative 0.3 t square plus 0.8 t, or Vy, this is the velocity of particle y, or velocity of particle y is negative 0.3 t squared plus 0.8 t. That means it's a negative quadratic graph. Well, now look at this. We will, here we forgot to write something. The constant value should be written, because we don't know what was the initial velocity when it started. The initial velocity was 7.5. Hence, our velocity of particle y is negative zero point 0.3 t squared plus zero point 0.8 t plus 7.5. 7.5. Then they have told, or plus c. Okay. Hence, remember, this is a very crucial point. Whenever you integrate, you should know the velocity. I mean, at that time, particular time, what was the value of velocity? Well, then they have told that the velocity was negative 9.6. So let us write v is equal to, when v is equal to negative 9.6, when our expression is also equal to 9.6. When, let us write, the expression is negative zero point 0.3 t squared plus zero point 0.8 t plus 7.5. 7.5 is equal to negative 9.6. After that, if we multiply everything by negative 10, it is going to be 3t squared minus 8t, and it is going to be negative, and that is positive, so it is going to be negative. So negative 96 minus 70, both of them will be actually now positive. No, it's negative. From 9.1, if we subtract, both of them will have to be added, because if point 9.6 is transposed to the left side, it will also be negative. So after doing addition, we have got it 96, 75, that means 170, 170, 171 is equal to 0. Now if we factorize, we will get 3, 171 is 353. So 353 can be broken, split into 27 and 19, yes. So 27t plus 19t plus 19t plus 19t minus 171 is equal to 0. Now if we factorize, it is 3t can be taken common, so if 3t is taken common, it is t minus 9, and the second factor is going to be 3t plus 19 is equal to 0. Hence, as t cannot be negative, so our t is going to be t is equal to 9 second, since t is greater than 0. Okay, so at 9 second the particle was moving at negative velocity. Okay, now we will have to find out the displacement it traveled in first 9 seconds. Okay, so before that we must draw a graph of that. For for let me change the ink. Let us draw a curve for this displacement. So this is velocity time graph, this is v meter per second, and this is t second. Okay, so the graph, look at this. At the beginning, initially what was the velocity here? Look at this, they have told it 7.5 initially. So our expression was this one. This is our velocity expression. So for this one, for this expression, if we look, it's a quadratic graph, quadratic function, but it is negative. It starts with a negative coefficient, so it is negative quadratic graph. That means it is n shaped. Okay, n shaped. So initially the velocity was 7.5. Let it be 7.5 over here. So what will be the shape of curve? As this is n shaped, it will look like this, and we have come to know that it was just like this. Okay, and we don't know when the particle was at rest, and that is even unnecessary also. We will find until 9. Look at this, here there is a huge twist. If we read the question, it says when the velocity of y is negative 9.6, show that we have already found that when the particle was at 9th second, then the velocity was negative 9.6. But they have told us to find the displacement. There is a difference, a very delicate difference between displacement and distance. In case of distance, we will have to find the total covered area, remember. But in displacement, displacement is only net distance, net change of position. Okay, so we don't need to add up in segment wise. There is no necessity of segment, so please don't get confused here. Look at this, sum of the part is above the graph. Okay, above x-axis, and sum of the part is below x-axis. So you may ask the question that if we find displacement, first we will find the upper part and then the lower part. So it is unnecessary here, because displacement means only the net distance. So total distance, that means the balanced distance after positive negative, the resultant one is the displacement. So remember, if you are told to find distance, then individually you will have to find the upper part, then you will have to find the lower part, and they will have to add it up. But if it is displacement, that means you will have to find the net distance. That means the lower part should be subtracted from the upper part. That's why directly we can apply the integration formula. Okay, I think you got my point, that we are finding displacement, so there is no necessity of finding the distances individually, segment wise. Just a net distance should be obtained. So for displacement, we will have to integrate the velocity. So for 0 until, let it be written, for our time is 0 until 9 seconds. Okay, then velocity of y is given as, velocity of y is negative 3t squared plus 0.8t plus 0.8t plus 7.5 plus 7.5 plus 7.5. Or if we integrate this, v velocity is integrated in terms of time, then it is going to be, let us integrate this. So it is going to be 0.3 over 3. Let me zoom it out. If we integrate, it is going to be 3 divided by zero point 0.1. So negative 1, it is negative 1, then t cube, and our time limit is what? Time limit is going to be 0 until, our time limit is 0 until 9. 0 until 9 plus, if zero point 0.8 is divided by 2, it is going to be 0.4, and our function is t square, and limit is from 0 until 9. 0 until 9 plus 7.5, 7.5 and 7.5 t, 7.5 t, and our limit, what is our limit? Limit is from 0 until 9. Then if we simplify, it is going to be, or our displacement, here also you can use this symbol. So our displacement of y is going to be 9 cube means actually 729, so it is going to be negative 72.9, 72.9 plus 9 square means 81. If we divide, if we multiply 81 by zero point 0.4, it is going to be, let us write 32.4, 32.4 plus, if we multiply 7.5 by 9, it is, because lower limit is 0, so 75, 9 equal to, it is 67.5, 67.5. So our displacement of particle y is going to be, if we add up these two and after subtraction we will get, it is 27 meters. So particle y traveled 27 meters in the first 9 seconds. Now we should know what was the displacement of particle x at this 9 seconds. And our displacement expression for particle x is already given. Let us see what was it. It was s equal to 3t raised to 3 over 2 minus 6t. Okay, so we can just copy this expression for sx. Sx is equal to 3, and our time is 9. Okay, t raised to, okay, let it be 3t raised to 3 over 2. 3 over 2, 3 over 2, and time limit is 0 until 9. 0 until 9 minus 6t. Okay, so we will write here 60. 6, 6, then t. Let me zoom it out. Now, if we calculate this, or s, I mean displacement of x is going to be, so 9 raised to 3 over 2 is actually 3 cube means 27. 3 into 27 is 81. Okay, 81 minus 6 nines are 54. Okay, hence our sx, that means travel distance of particle x at 9 seconds is 27, which is equal to, s of y. So they have told us to show and we have shown. Okay. Now once again I am clarifying that you may think that in the previous part when we found the distance of particle x, we have used this. Look at this once again, let me show you. Here for finding displacement of x we have found in two phases. Okay, that is one phase is this one. Here we have found first distance and the second distance was this. Okay, but in the final part, I mean in the solution to question number B, we didn't find that area or displacement individually because this was distance. Let me show you. Here they have told us to find the total distance. Look, here it is written total distance. It is about distance, whereas in question number B it is not distant at all, it is about displacement. So for displacement you will have to find only net distance. Okay, the negative distance is already subtracted from that one. That's why you don't need to find total distance and sum them up. It is simply will have to integrate and the net distance will be found. And finally we have shown that when the particle y was at 9 second and the at 9 second the distance or displacement, net displacement of particle y as well as particle x is 27 meters. Thus we have shown that both of them have traveled the equal displacement. Let's see the next question. The next question is from paper 429709/42 for the for the session May June 25. Let me show you. The next question under the same topic has been selected from paper 9709/42 for the session May June 25, and it says a particle P moves in a straight line and passes through the point A at time t equal to 0. The velocity v meter per second of P at time t second is given by v equal to 2t plus 1 raised to 3 over 2 minus 2t square, where 0 until time is 0 until 3 seconds. Find the maximum velocity. So for maximum velocity, what do? We just find the derivative of velocity is 0. Actually for maximum and minimum velocity, the acceleration is 0, means the derivative of velocity is 0. So let us find the derivative of the velocity. So our v is given, v is equal to 2t plus 1, 2t plus 1 raised to 3 over 2, 3 over 2 minus 2t squared. Now if we differentiate, the derivative is going to be dv over dt is equal to 0 for maximum. Okay, for maximum, let me write this. For maximum velocity, we know that derivative is 0. So dv over dt is going to be 0. If we differentiate this, it will be 3 over 2, 3 or 3 over 2 into, and the internal function has 2 as derivative, so it is 2. Then if we differentiate the function as a whole, that is 2t plus 1 raised to half. If we subtract 1 from the given exponent, then it is going to be 4t. Okay, and right side is our 0, so it is going to be 3 into 2t plus 1, that is square root of this, equal to 4t. Now to remove this square root, we can multiply everything by square. I mean we can square both sides, so it is going to be 9 into 2t plus 1, 2t plus 1 equal to 16t squared. Okay, so finally the expression is going to be 16t squared or 16t squared minus 9 2s are 18t minus 9 1s are 9 and 9 16s are 144. So 26 and 4, 26 24 and 6, 16t square minus 26 24t 24t plus 6t minus 9 is equal to 0. If we factorize, then it is going to be both of them are having 80 common, so 80 goes away, so it is 3t minus 4, 3t minus 4 and 8t plus 3. Hence our t is going to be actually 3 or 4 over 3. Sorry, we made a mistake. Let me erase this. If 8t is taken common, it is going to be 2t actually. So 2t minus 3 8s are 24 and again 8t plus 3 equal to 0. So our value of t is going to be, hence our t is going to be 3 over 2. 3 over 2. Since we cannot accept the value of t as negative, t is greater than 0 or equal to 0. So t is equal to 3 over 2. Now they have told us to find the velocity at this time. Okay. So let us write t is equal to t equal to 3 over 2 when v is equal to, when v is equal to, let us write our expression is this. This is the expression we have been given. 2t, that means 2 into 3 over 2, 2t plus 1 and our exponent is 3 over 2 minus 2 into, that is 3 over 2 whole square, 3 over 2 whole square, or our velocity is going to be here 2 to so 4. 4 cube means, I mean 2 cube, 2 cube means 8. So it is 8 minus, here 3 square means 9 and 2 square means 4. So 9 over 2, 9 over 2 is 4.5, 4.5. Hence our velocity is going to be actually 3.5 meters. Meter per second, meter per second, when the time was 3 over 2 seconds. Let's see what the next one says. Question number B says, it is given that in the interval 0 until 3 seconds, the velocity of p is always positive. Find the distance of p from A at the instant when p is moving at this maximum velocity. So it's already positive, they have mentioned. So our velocity expression is v is equal to what? 2t 2t plus 1 raised to 3 over 2, 3 over 2 minus 2t square. And as we are finding for the distance, look at this, and it is already positive, so there is no necessity of drawing the curve. We will get it positive definitely. So if we integrate velocity, then we will get the v in terms of dt. And our time limit is 0 until 3 over 2. The time was 3 over 2. So let us write this. It is 0 until 3 over 2 and our function is 2t plus 1 raised to 3 over 2, then dt minus 2 and our time limit is 0 until 3 over 2 and it is t square in terms of t, or our displacement is going to be S is equal to now, first of all, if we increase this power, it is going to be 5 over 2, so 2 over 5, 2 over 5, 2 over 5, and if we integrate the internal function, this 2 will go down, and our function is going to be now 2t plus 1 and 5 over 2, 5 over 2, 5 over 2. Then our limit is 0 until 3 over 2 seconds minus 2, and here it is going to be 3 over 2, and t is actually cube, and our limit is 0 until 3 over 2 seconds, means 1.5 seconds. After that, s is equal to 1 over 5. 1 over 5 means actually 0.2. 0.2 into, now look at this, if we substitute here 2 into, so let me show through substitution, it is 2 into 3 over 2 plus 1 plus 1, and limit is 0 until 3 over 2 minus 2 over 3 into, as the lower limit is 0, so it is going to be 3 over 20, so 3 cube means 27 and 2 cube means 8. Or our displacement is going to be 0.2 into, here lower limit is 0, so there is no necessity of counting lower limit. Upper limit is 3 over 2, so it is 3 into 3 over 2. That means, but we skipped something. Look at this here. The internal function has 5 over 2. So let it be written once again. Now, if we simplify more, it is going to be 3 plus 1, 4. 4 raised to this. So 2 raised to 5. 2 raised to 5 is, so it is going to be 4. 2 square means 4. 2 raised to 5 means 32. It is going to be 32 minus, it is 54 over 24. It is not 32, it should be 31 actually, because we'll have to subtract 1. If we subtract 1, then it is going to be 31. And finally, our displacement traveled by the particle is going to be 3.95 meter. And that is the answer to the part of this question as a whole. Okay. Let's see what the next question says. So the next question belongs to paper 9709/43 for the session May June 25, and we are solving question number 7. It says a particle x moves in a straight line. The displacement of x from O at time t second after leaving O is s meter, where the expression of s is given at this, and they have told us to find the velocity, and we know if we find the derivative of displacement we get the velocity. So s is equal to, let's write the expression 0.3 t squared, 0.3 t squared plus 0.6 t. So this is the expression for displacement. Now if we find the derivative of displacement in terms of t, it is going to be 0.6 t then plus 0.6. Okay, and they have told us to find t equal to 4. So t equal to 4 when t equal to 4, t equal to 4 when our v is going to be zero point 0.6 into 4 plus 0.6. Okay, then it is going to be nothing but 3.00 meter per second. second, which is the answer to the simplest part of this solution. Then B says for t is greater than 4, the acceleration of x is at time t second after leaving O is a meter per second square, where a is equal to 0.3 t raised to half. There is no change in the velocity of x at t equal to 4. The velocity of x at t equal to uppercase t is equal to 14.2 meter per second. Find the value of t. So we will have to find the value of t. Let's see how to solve this. So here expression is given when for t is greater than 4 seconds. Our acceleration is given point acceleration is 0.3 t raised to half. Now we should know the velocity first of all by doing integration. So a in terms of t, if we find the velocity, it is, if we integrate this, it is going to be 3 over 2. So zero point 0.3 into 2 over 3, and the exponent of t, the degree of t is going to be 3 over 2, and we should not forget about the constant value at the beginning, or v is equal to v is equal to, so it is going to point 1 point 2 t raised to 3 over 2 plus c. Now we will have to find the constant value. It is written that t is equal to 4. They have told there is no change when t was 4. Look at this change in the velocity x equal to t equal to 4. So we can use t equal to 4 when our velocity was, our v was what? V was 3 meter per second. Already we have found here. Look at this. When v was 3 meter per second, t was 4. So let us substitute the values. V is equal to 3. So our V is what? Point 2 t is, it is 4. So 4 raised to 3 over 2 plus c equal to 3. Hence our c is going to be, so point 2 into 4 raised to 3 over 2. So our C is going to be, it is 1.6. If we subtract 1.6 from 3, it is going to 1.4. Hence our expression for velocity, okay? So expression for velocity, hence our V is equal to, let me continue writing over here. Hence our V is equal to expression of V is 0.2 t raised to 3 over 2 plus 1.4, not 1.1, it was 1.4. C is equal to 1.4. Okay, this is our velocity. Then they have told us to find the velocity when time was t. Okay, so let me zoom it out. So it is written t is equal to uppercase T when our velocity is, our V is given 14.4. So let us substitute the values. Our velocity expression is zero point 0.2 t 3 raised to, so instead of t we can write uppercase t raised to 3 over 2 plus 1.4 is equal to 14.2, or t raised to 3 over 2. If we subtract 1.4 from 14.2, 2, it is going to be 12.8. So 12.8 over 12.8 over point 2. Hence our t is going to be, hence our t is going to be, or t is equal to, if we divide this, it is going to be 64. So 64 raised to, it will be reverse reciprocal, so 3 over 2, 2 over 3. Okay, hence our t is actually 4 square. 4 square means 16. T is 16 seconds. 16 second, which is the final answer to this part of this question. Okay, let me show you whole of this solution. So we got the value of t as 16 second. Let's see what the next one says. The next question is over here, which says that find the total distance. This is again distance traveled by x between t equal to 0 and t equal to greater uppercase T, which is 16. Okay. Before we find the distance, let's draw the nature of the curve. Look at this. For the first phase, it starts from 0 and this is v meter per second, and that is time t second. Okay. Now at the beginning, look at this, there are two phases. First phase was until first 4 second, and second phase was until 16 second. Well, so let us see what was the nature of the first one. First part was, look at this, for first 4 seconds it was, our velocity expression was this. Look at this, this was our velocity expression. Okay, so it is actually 0.60. That means it's a linear, positive linear graph. Okay, so it's a straight line. Let's draw this straight line until 4 seconds. It will be until 4 second, it is a straight line. And initial velocity, okay, we should know the initial velocity was 0.6. Let us write here 0.6. 0.6. So it was just a straight line like this. Then the next part, what about the next part? The next part is, next equation is, I mean our velocity graph is this one. This is our velocity graph for the second phase. For the second phase, it is also positive, but it's a graph, not straight line. It's a curved line, but it is positive, which starts from 1.4. Okay, so let us draw this. It continues until 60 second. Okay, 16 second, and as it was positive, it will look like somewhat this, and we require until 16 seconds. Okay, so this one, first part is our straight line, then second part is a curve, positive curve. For the first 4 seconds, our displacement one, it was given already, expression was given by the question, which is point 3. Let us write for 0 until 4 second. Okay, for first 4 seconds they have already given, it was point 0.3 into point 0.3 into point, as lower limit is 0, so it is going to be point 0.3 into 4 square, 4 square plus point 0.6 into t. T means 4. So our displacement is going to be, finally it is going to be 7.2 meters. 7.2 meters. Now the for the second phase, for 4 until 16 seconds. Okay, this is, we know the velocity, so we will find the, will integrate the velocity of v dt until 16 seconds. 16 second is equal to, if we integrate our velocity, our expression for velocity was point 0.2 integrate it to t raised to 3 over 2 dt plus 1.4 it was 1.4 then 1 it was 0 until 16 second, limit is 0 until 16 second is dt. Okay, let me show you whether we have written correctly or not. From the previous page we can see for the second phase, look at this, for the second phase it was, our velocity was this was the expression for velocity, that's why we have written point 0.2 t raised to 3 over 2 plus 1.4 into 1. Okay, now if we simplify or substitute the values, it is going to be, this is our S2, let it be the second phase. So point 2 and t, what will it be? It is given 3 over 2, that means 1 and half, so it is going to be 2.5 over 2. So 5 over 2 will have to multiply by 2 over 5 and t is 5 over 2. Our limit is from 0 until 3 over 2 plus 1.4 and it is going to be t. Our limit is going to be 0 until 16. Well, or point 0.2 and point 0.4, so it is 0.08. 0.08, then our time is 3 over 2. First one is 3 over 2. How many times? As lower limit is 0, so we can avoid multiplying by lower limit. It will also be 0. So into point, I mean 3 over 2 raised to how many times? 5 over 2 plus 1.4 into lower limit is 0. That's why it is just upper limit. Hence our S2 second phase is going to be, let us use our calculator. We have been making a great mistake. It is not 0 until 16. It is actually, we are calculating for the second phase 4 until 16. So it is 4 until 16. If it is 4 until 16, it is going to be 0.08, 0.08, then 16 raised to 5 over 2, 5 over 2 minus 4 raised to 5 over 2, 5 over 2 plus it is 1.4. From 16, if 4 is subtracted, it is going to be 12. Then using our calculator we will get, that is it is going to be 16, that is 4 square, 4 raised to 5 is 512 and 2 raised to 5 32. So totally we are going to get our 96.16. It is 96.16 is the displacement in the second phase. Here displacement and distance will be same because both the curve is lying above x-axis. Then we will have to find the total. They have told us to find total, hence total distance is equal to total distance is equal to, first distance was 7.2 meters and second distance was 96.16 meter. If we add up, it is going to be 103.4. So if we round it up to three significant figures, it is going to be 103 meters. Okay, so that's all about the solution to question number second part of B. Let's see the final question under the same topic. The next question belongs to paper 9709/45 for the session May 25, and we are solving question number 6, which belongs to the same topic we are discussing today. It is a particle P moves in a straight line starting from a point O. At time t second after leaving O, the velocity v meter per second of P is given by v is equal to 15 minus 2t whole squared. Find the values of t when the velocity of P is 100 meter per second. Well, so velocity is given. They have told v equal to what? They have told it is 100 meter per second. 100, okay? Or v expression of v is 15 minus 2t whole squared is equal to 100, okay? Or 15 minus 2t is equal to positive negative 10, okay? Now we require actually t, so t will have two values, hence our t is first value. If we add up 15 to 10, it is going to be 25, okay? If both of them are having same symbol, then it's so 25 over 2 is 2.5. And another one is, if 15 is having positive but 10 is negative, then it will be 5. So 5 over 2 is 2.5. First one is 2.5 and another one is 12.5. Well, both of them are acceptable because both of them are having positive symbol. Then the next question, immediate next one says, show that there is a particular value of t for which the velocity and acceleration of the particles are both 0. So v is equal to 0, first one. We are going to find v is equal to 0 first. V is equal to 0. So if v is equal to 0, our expression for velocity was what? 15 minus 2t whole squared. 2t whole square is equal to 0. Or our, if we expand this, it is going to be 225 or 4t square. 4t squared minus 30t plus 225 is equal to 0. Okay. So finally we will find that 15 minus 2 is equal to 0. Okay. So without expansion also we can write this. You may raise a question, what is the necessity of expansion of this? I will let you know later on, it is necessary, but it is simply what? It is 15 minus 2t into 15 minus 2t actually. Okay, 15 minus 2t is equal to 0. Hence, as both of them are having same value, it is t is equal to 7.5. But it is required later on. Well, this is for time when velocity is 0. Then for acceleration also it should be 0. Okay, let us find the acceleration. v is equal to v is equal to v is equal to what? 15 minus 2t. 15 minus 2t whole squared. Okay, then for acceleration we will find the derivative of velocity. dv over dt, it is going to be 2 and minus again 2, it is 15 minus 2t. 2t and it's equal to 0. Okay, or negative 4 15s are 60, negative 60, then plus 8t is equal to 0. Hence our t is same, it is 7.5. So we have found that in both cases time is 7.5 when velocity was 0. For t is equal to 7.5, velocity is 0, acceleration is 0. At the same time, when time was 7.5 seconds, then velocity was also 0. We have shown that it is shown. We can write here shown. They have told us show. So we have shown. After that, let's move on to the next solution. Next question is on the next page here. Find the displacement of P from O at the time that velocity and acceleration of the particle are both zero. That means T was 7.5. Okay. Before moving on to the displacement, we should draw the curve, as this is actually our curve should be shown. Look at this. This will be t second velocity time graph. It is 0, and that is v meter per second. Well, our expansion, I mean, our expression was what for v? Our expression was this. That's why I told that this is necessary. Look, this was our expression. This one, look, this is now necessary. So it is just a quadratic graph. In quadratic curve, our initial velocity was 2 to 5. Okay, it is 2 to 5, and it is a u-shaped quadratic graph because this is positive. And look at this, when velocity was 0, our time was 7.5. At the same time, our acceleration was also 0 when t was 7.5. That means that is the turning point. So all this information should be inserted there. This is how will the curve look like. Look at this, at 7.5 the particle is at 0. At the same time, at 7.5 seconds, the acceleration was also 0 because this is turning point. Well, now we'll have to find v is equal to 15 minus 15 15 minus 2t whole square. Now we require the displacement, so s is equal to, we will have to integrate. If we integrate, it is going to be, should I show in terms of time? So if we integrate this, it is going to be first 1 over 3 degree will increase by 1, and negative 2 will go down. Then our inner function is going to be 2t. Okay, then our displacement is going to, and our limit is from 0 until first 7.5 minutes, 7.5. So it is going to be s is equal to negative 1 over 6. If we use upper value, it is going to be actually 0. 7.52 are 15 minus 15, 0. So upper value is 0 into the lower value is positive. So what is going to be, if t is 7.5, so it is going to be 15 cube. That means minus 15 cube. 15 cube. Hence our displacement is going to be, if we divide 15 cube by 6, it is going to be 562.5. 562.5 meter per second. You can round it up to 3 significant figures to write 563 meters. So that is what our final distance is. And that's all about the present topic. I mean, there is no more question left to be solved from this topic for the May June 25 session. And thank you all for watching this. Let's move on to the next topic.